that will be. Good morning to everyone. Good morning. Yes, I will be holding this cloth. No problem.
You can keep it there whenever you want.
Good morning. Fine. So we will start with the class. Okay. So before going to today's concept, as usual, 2 to 3 minutes we will have brief view on the whatever we have discussed in the last class. Fine. So now, with respect to the last class, if you remember, we have discussed about 3.3 and 3.4, right? So 3.3 and 3.4, especially 3.3 we have discussed. Now, if you remember, what is there in 3.3 or what we have discussed in the last class? So that is related to features of the modern periodic table. So that is related to features of the modern periodic table. That's what we have discussed. Features of the modern periodic table. Can anyone tell me, any one sentence, what are those features? That means we are answering how elements are arranged, how it has been created, on what basis it has been created. So that's where, with related to how it has been created or on what basis it has been created, the answer will be based on the atomic number, right? So based on the atomic number. Now all of us we know modern periodic table. Yes, you are absolutely right, Gahan and even Mansi. You people are absolutely right. It is based on the atomic number. Very good, right? So that is one thing. Now when it comes to periodic table, modern periodic table, which is also called as long form of periodic table, which is also called as long form of periodic table, right? Now why it should be called as long form of periodic table? What is the reason? That is because when I am talking about long form of periodic table, that is because it is much longer than that of the Mendeleev's periodic table, right? Mendeleev's periodic table. That is one thing. Why it is so long compared to Mendeleev's periodic table? Because they have kept some space for the newly discovered element to enter the name of the newly discovered element. So due to that, it is much longer than that of the Mendeleev's periodic table. Fine. So therefore, they will call it as long form of periodic table. Fine. So yes, to accommodate the new elements. Absolutely correct. Fine. So that's where we have the long form of periodic table. Now, very important difference between Mendeleev's and modern periodic table is, in Mendeleev's periodic table it was based on atomic weight, but when it comes to modern periodic table, it is based on the atomic number. Or you can tell that Mendeleev's periodic table was following Mendeleev's periodic law, but when it comes to modern periodic table, it will follow the modern periodic law. Whether I am clear? Fine. So then we have discussed there will be presence of periods and groups. Periodic table will be having majorly two components. One is period and another one is group. So now, with respect to the groups, already we have discussed how exactly elements are present in the respective groups. Groups can also be called as, anyone? Groups can also be called as, okay, 18 groups and 7 periods. Absolutely correct, all of you. Absolutely correct. There will be 7 periods and 18 groups. But groups are also called as families. Yes, very good. Now, all of us we know that groups can also be called as families. Why they should be called as families? Why a group should be called as a family? That is because similarity in the outer electronic configuration. Similarity in the outer electronic configuration. That's where if I take group 1, all of them will have the outer electronic configuration as NS1, where n value depending on which period we are dealing with, right? So it will be NS1. So if I take group 2, now it can be NS2. Now it can be NS2, where once again n value will vary, but S2 will remain same, right? So that is because of the similar outer electronic configuration. Same if I go with group 13. If I go with the group 13, right? Directly I am skipping to P block elements. I will come to that one. So that is group 13. So that's where we have NS2 and P1. Right? So if I take group 14, that's where I can have NS2 and P2. Then group 15, that's where I can have NS2 and P3. Then group 16, I can have NS2 and P4. Then group 17, NS2 and P5. Then finally we have group 18, NS2 and P6. So that's where it has attained the octet state. Group 18, all of them they have the NS2 and P6 except helium. All of them they have NS2 and P6 except helium. Fine. So NS2 and P6 where n value once again depends on the period. If I am talking about second period, then it will be 2s2 2p6. If I am talking about third period, 3s2 3p6. Like that, n value will be increasing as you move down the group. Because when we are moving down the group, we are moving to the next period, like that we are moving. Due to that, there will be increase in the respective n value. But helium, which is also belongs to group 18, it is having NS2. It is having NS2 electronic configuration. All of you will agree? So it will have one S2 electronic configuration. So in that case, the question here will be, sir, if that is the scenario, why not helium will be included here in group 2? Why not helium will not be included in group 2? That is, the reason is very simple. Since helium has attained NS2 electronic configuration and it has completely filled orbital, because helium, what is the atomic number? Atomic number is 2, right? So therefore, energy level 1 is only available in helium. In ground state I am talking about. In the ground state of the helium, only energy level 1 is available. So which subshell is present? S subshell is only present. So how many electrons can accommodate? Maximum 2. So that's what it has done. It has accommodated 2 electrons. Done. There is no other empty orbital. Nothing is left over. Everything is completely filled. So it will be very, very less reactive. Someone has written. So therefore, due to its less reactiveness, group 18 elements are called as inert gas. Group 18 elements are called as inert gas. And old nomenclature, if you go with the old nomenclature, they will call it as a zeroth group. They will call it as zeroth group elements. So they are inert gas. Why they are inert gas? That is because they are very less reactive. So therefore they are called as inert gas. Since helium is also very less reactive, since helium is having completely filled orbital, so therefore helium is also included in group 18 only. It cannot be included in group 2. Group 2, they are reactive elements. They are reactive elements. I will come to that. All of you have understood why helium has been placed in inert gas group, although electronic configuration is different. Fine? All of you have understood? Now, I will come to group 17. Group 17 elements. Anyway, I will not go in detail. All these things you are going to discuss in detail in your second PU. P block element. One huge topic is there. There you are going to discuss. Okay, na? So that is group 17. Now group 17 elements are called as halogens. The reason is very simple. Halogen means they are salt producers. Halogens are nothing but they are salt producers. For example, NaCl, a common table salt, where we have the chloride, Cl minus. Chlorine is one of the element of group 17, right? Now if I observe it carefully, I have the chlorine. Now, what is the atomic number of chlorine? Can anyone tell me? Atomic number of chlorine. It will be 70, right? It will be 70. Now, if you observe it carefully, NH2, NP5. So, it will be NH2, NP5. So, it should be 17. Achyuta. Okay, na? So, when it comes to NH2, NP5, naturally, since chlorine belongs to which period? Chlorine belongs to which period? That is period number 3. So therefore it will have 3s2, 3p5. Right? Now, if it accepts one electron, if it take up one electron, now it will be becoming chloride. Atomic number will be same. There is no change in the atomic number. It will remain same. Okay? So yes, it belongs to period number 3. All of you are correct. So therefore 3s2, 3p5. Now we have the chloride. Chlorine, chloride. Right? So what is that difference between chlorine and chloride? When I am telling chlorine, I am talking about neutral atom. But when I am talking about chloride, I am dealing with the anion. I am talking about the anion. So naturally, chlorine will become chloride, anion. What are anions? Negatively charged ions, right? So they are called as anions. So chloride is an anion. How chlorine has become chloride? By accepting the electron. So due to that, electronic configuration will become, only outer electronic configuration I am writing. We will discuss about electronic configuration. That's where we have the 3s2, 3p6. That means group 17 element will attain the electronic configuration of neighboring inert gas. Group 17 element will attain the electronic configuration of neighboring element. Observe here carefully. If I have helium, then neon, then argon, then krypton, then xenon, then radon. Right? So, period 1, period 2, period 3, period 4, period 5, period 6. Period 7, don't worry. Okay? So it's not well studied. That's where we have the helium, neon, argon, krypton, xenon, radon. Because all of us we know helium belongs to period 1. So therefore 1, 2, 3, 4, 5, 6. Sixth period element is radon. Right? Now if I take group 17, group 17 elements, they will start from period number 2. That's where I have the fluorine, chlorine, then bromine, then iodine, then astatine. Right? So that's where I have the group 17. So what I mean to tell here is, now chlorine 3s2 3p5 was there. Now once it became 3s2 3p6, it has attained the electronic configuration of argon, not organ. Organ means biology students will get confused. Argon. Okay? So it has attained the electronic configuration of noble gas, that is argon. Please remember, I am not telling that chloride has become argon. No. That will be a wrong statement. Chloride has not become argon. What I mean to tell you is chloride has attained the electronic configuration of argon. Right? But still, atomic number is 17 only. Chlorine is also 17, chloride is also 17. Since one extra electron is there, because we have 18 electron here, since one extra electron is there, that will be mentioned in the form of one negative charge, which will indicate one extra electron in chloride. Therefore, please remember, due to this reason, due to halogens, which can take up one electron, they can easily become a noble gas. They can attain this stability. Please remember, all of you have studied in atomic structure, a completely filled atomic orbitals. A completely filled orbital will be a stable orbital. Completely filled orbital will be a stable orbital. Now I am talking about NS2 NP6, right? So what is the total number of orbitals present in p subshell? It will be 6, right? So it will be 6. So now 1, 2, 3. I am talking about electron. Okay, it will be 3 orbitals which are available. So therefore 1, 2, 3, 4, 5, 6. Right? So that means NP6 means I have got the completely filled p subshell. NP6 means I have got the completely filled p subshell. If I am talking about NS2, that means I have got completely filled S subshell, because S subshell is having only one orbital. Right? So this will be the stable electronic configuration. Now all of us we know in the nature, not only atoms, all the process, all the thing, every process in the nature, they are moving towards attaining the stability. They will be moving towards attainment of the stability. So that's where group 17 elements, they can easily attain the stability by accepting one electron. They can easily attain the stability by accepting one electron. So where they will reach to their respective inert gas configuration. That means fluorine will attain, if fluorine has become fluoride, then it will be neon electronic configuration. If chlorine becomes chloride, then it will be argon electronic configuration. If bromine will accept one electron, then it will become bromide. Then it will attain the krypton. Then iodine will become iodide. Then it will be xenon. Anyway, astatine will not discuss here because it's a radioactive element. That's where we have the group 17, halogens. So therefore in the nature, compared to chlorine, chloride is more stable. Compared to chlorine, chloride is more stable. Compared to bromine, bromide will be more stable. Compared to iodine, iodide will be more stable. All of you have understood? So that's where we have the attainment of stability. Fine? Whether I am clear? Now same logic is applicable for the hydrogen. Actually hydrogen in many of the cases they will show it in group 1. Right? They will show it in group 1. But this hydrogen whose atomic number is 1, if it takes up one electron, now it will become hydride. Which will be having electronic configuration of helium. That is 1s2, 1s2. Helium is having electronic configuration of 1s2. So hydrogen will accept one electron and will become hydride, then it will become 1s2. That means similar to that of the chlorine, even hydrogen should have taken one electron and it should have become hydride. So where it will attain the electronic configuration of helium. That means it would have attained stability. Right? So in that case, why can't we place that one along with group 17? Why can't we place hydrogen along with group 17 like neighbors, hydrogen and helium as the neighbors? Right? But if you remember, in your high school, you people might have discussed about the pH. What is pH? pH is nothing but negative log of H plus concentration. That means I am talking about H plus. That means there is an existence of H plus also. Right? So there is existence of H plus also. Yes, Gahan. It is power of hydrogen. P stands for power of hydrogen. But pH is equal to negative log of H plus concentration. So that means hydrogen can be present as H plus also, which we will generally call it as a proton because there is no electron, only proton is there. So we can call it as a proton, H plus. Right? So that means in the nature we have hydride also, H plus also. Donating the electron is the property of group 1. So that's where sodium will become Na plus, potassium will become K plus. All of them they belongs to group 1. Now the question comes, sir, whether hydrogen will behave as a alkali metal, that is group 1, or whether hydrogen will behave as a halogen, group 17. Confusion. Right? So therefore, in your NCERT textbook which has been given properly that hydrogen has been placed at the top of the periodic table. Anyway, in detail I will not go with this because you people are going to discuss these things in your hydrogen topic. Right? So, but someone had asked, I don't remember, some question was there on hydrogen, first day of the class. So therefore I am mentioning, first day or in some class they had asked. Right? So therefore it has been placed top of the periodic table. Not in group 1, not in group 17. It has been placed on the top of the periodic table. Right? But still, hydrogen becoming H plus is very common in the nature. Hydrogen becoming H plus is very common in nature. Therefore, it has been placed in many of the periodic tables. It has been placed along with the group 1. It has been placed along with the group 1. Right? So, any doubts? Any doubts? So what I mean to tell you is what we have discussed just now here is based on this we can tell that an element which comes under particular group, that means it will be having similar outer electronic configuration. outer electronic configuration. That's what we can conclude based on whatever discussion we have done. Right? So what is that? So therefore groups, whatever families, those elements will have similar outer electronic configuration. That's what we can conclude. That's what we can conclude. Fine? All of you have understood? Okay? Now, when it comes to periodic table, it has been classified into different blocks. Like Mysore, we have Gokulam, then Padavaralli, then we have Vijayanagar. So like that we have different area within the Mysore. Same way, even your periodic table has been classified into different blocks. So that's where that is depending on the S subshell, P subshell, D subshell and F subshell. Yes, as Achita has written, yes, we have S block element. Yes, we have the S block elements. Then we will be having P block element. This is actually small s. It looks like I have written capital S. So then we have the P block elements. Then we have the D block elements. And finally we have the F block elements. Finally we will be having the F block elements. Fine. Now before going in detail, before writing their general electronic configuration, first we will talk about some of the electronic configuration of some of the elements which people have already discussed or studied in your atomic structure. Pauli's exclusion principle, right? Then we have the Hund's rule of maximum multiplicity. During that time, already people have studied about how to write the electronic configuration. Now to write the electronic configuration, first we should know inert gas, helium, then neon, argon, so krypton, xenon and radon, right? Now helium atomic number is 2. So add 8 to helium, that will become 10, difference of 8. Then once again add 8 to this, so we have got the 18. Now add 18 to this, then it will become 36. Now add 18 to 36, how much it will be? It will be 54. So add 18 to this. Now add 32 to 54, then it will become 86. Right? So that's where we have the difference of 8, 8, 18, 18, 32. Right? So that's where we have the difference, because when it comes to period, first period can accommodate 2 elements. Second and third period it will be having 8 and 8. Fourth and fifth period will be having 18 and 18. And sixth and seventh period will have the 32. Since we don't have seventh period, we have stopped at sixth period, so therefore only 132 is coming. Fine? So if you remember these numbers, you can write the atomic number for any of the element. Okay? But you should know first atomic number. Fine? So this is where we have the atomic number. Now we should know about the Aufbau diagram. 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d, 6f. Okay, I will stop here. Then electrons should be shown, how it will be fit. In your exam, you can write it on corner of a sheet, these information, to avoid the mistakes. Okay? To avoid the mistakes, on the corner of a sheet, your answers, you can write this one. You can mention it as a rough work. No one is going to deduct the marks for that. Fine? Now, what will be the electronic configuration for sodium? What will be the electronic configuration for sodium? Okay? Because when it comes to S block, we have group 1 and group 2 elements. We can have the group 1 and group 2 elements. I will go with regular numbers only. Group 1 and group 2. Okay? Now I am talking about sodium. Atomic number is 11. Sodium atomic number is 11. Right? Now, Sri Vidya. So that 281, fine. But that was applicable for your, okay, fine. Since it was, you are typing, fine, I agree, 281. But in your exam, you should go with the subshell notation, proper electronic configuration. This one is fine. Since you are typing, it's not possible. So sodium, it is 11, which is near to the neon. Neon is having one less. So I will write it as neon 3s1. Why I am writing 3s1? Because when I am talking about neon, up to here, it is done. 1s2, 2s2, 2p6. When I am writing neon in this square bracket, so I have written the electronic configuration up to here. So after that it will be 3s. So just 3s1 I have written. I have written it as 3s1. Fine. All of you will agree? Now, this sodium can have the stable electronic configuration. This sodium can have the stable electronic configuration either by removing this one electron, that is the only possibility, or you should take up extra 7 electrons. There are two possibilities. One is it will remove one electron and it will become Na plus, atomic number will remain same, and it will have the electronic configuration of neon because there is nothing on 3s. It has become 0, right? Or it should take up 7 electron and it should become Na minus 7. So don't worry, Na minus 7. So neon 3s2, 3p6. Right? So these two possibilities are there for sodium to attain the stability. Naturally, it's not at all possible. No element can take up 7 electrons. It's impossible. Right? So therefore, it will go with the donation of 1 electron to attain the neon electronic configuration. To attain the neon electronic configuration. So that's where we have in the nature NaCl, where it will be, when you dissolve sodium chloride into the water, it will become Na plus and Cl minus. Right? So that's where sodium has donated 1 electron to chlorine. When sodium and chlorine will approach to each other, chlorine will tell, give me 1 electron, I will attain this stability. And sodium will tell, oh, take up 1 electron, even I am going to attain the stability. They will come to a conclusion, okay, fine. Since both of us we are attaining the stability, I will give 1 electron to you and you take up 1 electron. Right? So that's where Achita, I am not going to discuss much about the bonding here, but try to understand. Okay? So that's where I am having Na plus Cl minus. So group 1 element, they are actually S block elements. Group 1 elements, they are actually S block elements. All of you will agree? Group 1 elements are S block element. Don't forget, which are called as alkali metals. Group 1 elements can also be called as alkali metals. Now word metals. They are called as alkali metals. Sodium, potassium, lithium, all of them they belongs to this category. Group 1. Okay. Now I'll talk about group 2. Group 2. I'm focusing on neighbor of sodium, that is magnesium. Magnesium is next to the sodium. Natural atomic number should be 12. Sodium is 11, magnesium should be 12. Right? Okay, Gahan. Yes, you are absolutely right. They are soft metals, no doubt. So that's where I have the magnesium. Fine. Now, if I want to write the electronic configuration, actually I should take the help of neon, no doubt. Because argon is more than 12. It is 18. So I should take the help of neon. So it will be 3s2. It will be 3s2. Someone had already written. Yes, it will be 3s2. Fine. So that's where I have the magnesium electronic configuration. Okay, fine. Very good. All of you are taking strain in making that bracket, which still people are writing. I appreciate. Very good. So that's where we have the magnesium, which is having 3s2. Now once again, magnesium is having, or it has to attain the stability. Please remember, all the elements they want to have the stability. All the humans, we want to attain the stability. Right? So that's where it has to attain the stability. So one is, it can take up 6 electron and it can become magnesium minus 6. Right? So where neon 3s2, 3p6. Right? Or it can donate the 2 electron and it can become magnesium plus 2. Atomic number will remain same and it will attain the electronic configuration of neon. Because there is nothing in 3s. No need to even write 3s0. But to make you understand, I have written. If you write also, no problem. Already people are writing the compound. Very good. So that's where we have the magnesium, which has been donating 2 electron. Fine. So that's where we have the magnesium. Now, magnesium can donate 2 electron, but 1 chlorine can take up only 1 electron. Chlorine will not going to compensate. Oh, magnesium, you want to attain the stability, give me 2 electron. No chance. Chlorine, 1 electron only. So therefore, magnesium will donate 1 electron to 2 chlorine atom, and in turn they will become magnesium chloride, MgCl2, NaCl, but here MgCl2, because 1 chlorine cannot take up 2 electron, but magnesium is going to donate 2 electron, not less than that, not more than that, no doubt. It will be exactly 2 electron which can be donated by the magnesium. So therefore, magnesium chloride formula will be MgCl2, because 2 chloride will be formed by accepting 1 electron from the magnesium. Fine. Same way, calcium chloride, it will be CaCl2. That is because calcium is exactly at the bottom of the magnesium. So calcium, magnesium, everything, they belongs to the same group. That is group 2. They are group 2 elements. So naturally, these elements are called as alkaline earth metals. Anyway, in detail, you have separate topic in part 2. That is S block element. I am not going to discuss in detail. So this is what we can have the conclusion. So when it comes to group 1, they are called as, group 1 elements are called as alkali metals, and group 2 elements are called as alkaline earth metals. Fine. So that's where we have the conclusion. Now, if I want to write the general electronic configuration, I can tell NS1, 2. Right? And all of them, both are metals. Both are metals. So alkali metal, alkaline earth metal. Why they are called as alkali and alkaline earth metal? Anyway, you people are going to discuss in S block. Fine. So that's where we have the S block element with general electron configuration as Ns1 for group 1, Ns2 for group 2. All of you have agreed, and both of them, one can go with the 1 positive charge, another can go with the 2 positive charge. Fine? Like sodium Na plus, magnesium plus 2. That's where we have the S block. Okay? So in detail about metals and all, we are going to discuss, don't worry. But for time being, these are the two groups which belongs to S block. Natural, two groups only can belongs to S block. Why? Because S subshell can accommodate only 2 electrons. Since it can accommodate only 2 electrons, only 2 groups should be belongs to S block, not more than that. Right? So that's where we have the 2 groups. Now, when it comes to P block, right? So now, when it comes to everything we are going to discuss, but first we will talk about these different blocks in the periodic table. Fine? Now when it comes to P block, how many electrons can be accommodated by the P subshell? Total how many electrons will be accommodated by the P subshell? It will be 6 electrons. Because P subshell is having 3 orbitals. Each orbital can accommodate maximum 2 electrons. So 3 into 2, 6 electrons. So right? So therefore, how many groups will be there? Yes, it should be 6 groups. Therefore, since P subshell can accommodate maximum 6 electrons, there will be presence of total 6 groups. So that is group 13 to group 18. From group 13 to group 18. Fine? So that's where we have the P block element. So group 13 to group 18. Now, whenever I am talking about P subshell, once 2s is getting filled up, immediately is going for P subshell. 3s, immediately it is going for 3p. 4s, immediately it is going for 4p. In their respective energy level I am talking about. Right? But when it comes to energy level 4, before filling of the 4p, 3d is entering into the picture. When I am talking about 5s, before filling of 5p, 4d is entering into the picture. When I am talking about 6s, before filling of 6p, 4f and 5d is getting filled. Try to understand this. If you understand the flow diagram, the whole story can be explained. Now if you observe it carefully, period number 2, only we have the P subshell. Therefore period number 1, we don't have P subshell because energy level 1, we don't have P subshell at all. So from period 2, P block elements should start. So that's what it is happening, except helium. Okay, na? So that's where we have the 2s, 2p. Now 3s, 3p. Up to 3 periods, there was no issue. After 3s, 3p was getting filled up. After 2s, 2p was getting filled up. But when you are coming to the 4th period, I am talking about energy level 4. Now, before filling of 4p, 3d will come. Right? So, after 5th period, 5s, before filling of 5p, 4d will come. So, that means when I am talking about from period number 4, now P block will be having, I can tell, prior elements which are called as D block elements because D subshells they are getting filled up. Anyway, I will come to that when I am talking about D block elements. So now for time being, remember that when it comes to P block, the electronic configuration will be NS2. S subshell will be completely filled. NP1 to NS2, NP6. That will be the general electronic configuration for P block. NS2, NP1, 2 to NS2, NP6. That's where we have the general electronic configuration for P block. All of you have understood why P block element always start from period number 2? That is because at energy level 1 there is no availability of P subshell. P subshell availability is only from energy level 2. So therefore P block always it should start from period number 2 and it can go up to period number 7, no doubt. It can go up to period number 7. That is one thing. Now when it comes to P block, it is having different category of elements. When it comes to S block, we have alkali metals, alkaline earth metals. That means only metals were there. Right? Only metals were there. But when it comes to P block, we will be having metals, metalloids, and even non-metals. All the different category of elements we can observe in P block, and this is the only block in the periodic table where we can observe all the three categories of elements. We can have metals also, we can have the metalloids also, and we can have the non-metals also. But in S block, only metals, right? So in transition metal, D block, only metals. So what I mean to tell you is, P block is the only that particular block in the periodic table where we can have all the types of elements. Fine? All of you have understood? So that's where we have the speciality of the P block. Therefore, they can also be called as representative elements. They can also be called as representative elements. Fine? So even sometimes even S block they will call it as representative, but P block will be called as representative elements because they are representing all the category of elements. They are representing all the category of elements. Some people they will tell that representative elements means based on their reactivity, uniform nature. So due to that they can call it as representative elements. If I tell representative elements are those which are having uniform character or similar features, then I can tell that S and P block will be representative elements. But if I tell representative elements means where all the different types of elements can be observed, then P block can be called as representative elements. All of you have understood? That is one of the important things. That's where we have the representative elements. Right? Now, if I observe P block, silicon, germanium, all of them, they are metalloids. Silicon, germanium, polonium, they are all actually metalloids. Right? But some of the elements which are at the bottom of the periodic table in P block, at the bottom side, it can be bismuth and all, they are called as metals. They are called as metals. But when I am talking about nitrogen, oxygen, fluorine, all these things, all these elements are non-metals. All these elements are non-metals. Or in short, I can tell that in the P block, I am not talking about the whole periodic table. In the P block, non-metals are more. Then comes the metalloids and metals. Fine? But non-metals are more in number in P block. In S block, only metals are present. Okay? So if someone asks you, in the periodic table, which are those elements in the periodic table where we can find the non-metals, then you can tell that p block elements. We can call that p block elements. Fine. All of you have understood, which is also called as representative elements. Right? So due to their reactivity, we can call them as representative elements. Fine? All of you have understood? Any doubts? I think someone has written. They are called as representative element because they have incomplete outermost shell. Absolutely fine. So that's where their reactivity comes. Fine? All of you have understood? Any doubts in this? Now therefore this is the general electronic configuration for p block, NH2, NP1, NH2, NP6. Now can someone write the structure of electronic configuration of nitrogen, which is a p block element. Electronic configuration for nitrogen. Atomic number is 7 for nitrogen. Right? So naturally I should take the help of which inert gas? That is helium. Because neon is 10 more than 7. So I should take the help of helium. Now this will have the electronic configuration because it belongs to period number 2. 2s2, 2p3. Right? So 2s2, 2p3. So 3 plus 2, 5 and 2 here, 7. Total 7. So 2s2, 2p3. Right? So can any one of you write the electronic configuration for carbon, neighbor of nitrogen? Atomic number is 6. Naturally, once again, helium, then 2s2, 2p2. Right? Can any one of you write the oxygen, neighbor of nitrogen? It will be 8. Once again, helium, then 2s2, 2p4. Fine? So that's what we can have the conclusion, right? That's where we have the electronic configuration. Now can you comment on the electronic configuration? Can you give some comments on this electronic configuration? So carbon is 2s2, 2p2, nitrogen is 2s2, 2p3, oxygen is 2s2, 2p4. All are p block but belongs to different group. So group 14, so therefore 4 valence electron. Group 15, therefore 5 valence electron. Group 16, therefore 6 valence electrons. That's how we can easily remember. Except transition metals, all S block and P block, we can easily tell what is the total valence electron because of that group. So group 1, 1 valence electron, group 2, 2 valence electron, group 13, 3 valence electron, group 14, 4 valence electron, group 15, 5 valence electron, group 16, 6 valence electron, then group 17, 7 valence electron. Like that we can easily tell. Fine? So that's what we can observe. That is one thing, that's fine. But anything extra comment? You people have studied about all these things in your atomic structure. May not be specifically, but in general. Okay, so that is fine, Gahan. Naturally, in the periodic table, atomic number will be increasing, and when you move from left to rightward direction or from top to bottom side, that is fine. I can tell that nitrogen is having bit stable electronic configuration. Nitrogen is having slightly stable electronic configuration. Why? Because it is having half filled. It is having half filled p subshell. It is having half filled p subshell. That means when I am comparing group 16, group 15 and group 14 or any of the p block other than the inert gas, group 15 is having slightly stable electronic configuration because all of you have studied in your atomic structure topic that a completely filled orbital and half filled orbitals are stable. They are considered as stable electronic configuration. All of you have understood? Any doubt? Once again, anyway, I will stop here. But whenever I am discussing in tomorrow's class, we have to understand and we have to discuss still about D and F block. But any doubts here? Fine? So briefly I will tell what I have discussed today, because I had written many things on the board. Some of you might have got confused, or I don't know, but anyway, I will be telling what I have discussed. Till I am in, I have jumped to 3.5, please remember. 3.4 I have skipped, that one I will come back. But today what I have discussed is, it is related to 3.3 of your textbook and 3.5. I have skipped 3.4 concept. Fine? So that's what I have discussed. So what we have discussed is S and P block elements. Now S block elements, first group 1 and group 2 belongs to S block, which are metals. So group 1 elements will be considered as alkali metals and group 2 elements will be considered as alkaline earth metals. Right? Now comes the group 13 to group 18. That's what we have discussed, which belongs to P block. So in the P block we have general electronic configuration as NS2 to NP1 to NS2 to NP6. So that is the general electronic configuration. Now group 18 already we have discussed, they are inert gas, they are stable, that is because of the stable electronic configuration. Why group 18 they have the stable electronic configuration? Because they are having completely filled orbitals. But when it comes to rest of the P block, we have group 15, which is having half filled electronic configuration. I am talking about P subshell, half filled electronic configuration. So therefore even they are having quite stable electronic configuration. Remember this. Fine? So that is one thing. And P block elements can be considered as representative elements. Even sometimes S block will be included in this category. That is because of their reactiveness. Right? Now when it comes to P block, we have metals, metalloids and non-metals. All these types of elements comes under P block, and this is the only region of the periodic table where we can observe all the three category of elements. That is metals, non-metals and metalloids. No other block of the periodic table have all these categories of elements. Fine? So anyway, I will stop here. Any doubts? Okay. And please practice, try to practice up to 35 elements, minimum 35. That is, I think, enough. In your exam, you can have the 1 mark question in such a way that write the electronic configuration for nickel. They may not give atomic number. Then you should be knowing the atomic number, right? Then Aufbau diagram, practice. Then helium, inert gas, you have to practice. Okay? Or they can ask, why I am telling to practice this too, because they can ask that write the electronic configuration for element having atomic number 80. They may not give the element also, you may not be requiring the writing the name of the element, just write the electronic configuration. But when I am writing 80, then you have to remember the inert gas. Sir, what is the difference between metals and transition elements? Okay, that one we are going to discuss in the D block. So D block elements are called as transition because if you see the position of D block and F block in the periodic table, they are exactly in the middle. One side it is S block and another side it is P block. S block, they are metals, and P block maximum they are non-metals. That means there is a shift in the character of the element from metallic to non-metallic. Therefore, in between elements are called as transition. There is a transition, right? So metals to non-metals. Okay, so due to that they are called as transition metals. That's all. Okay, therefore they are called as transition elements. Anyway, we are going to discuss that one in D and F block. Fine. Any other doubts? Okay. So tomorrow we will continue. Take care. Bye. Hmm? Okay. Transition element, because they have incomplete penultimate shell, that is fine, but that not be universal also. All the transition element may not be applicable, but fine, that is also fine. But you can easily remember like this, since it is a center of the periodic table where we have on this one side metals and on the other side non-metals. Okay, thank you.